Hi everyone, let's continue our session for the third tutorial. We're gonna discuss about two problems here. The first one is high-low method and regression analysis. Alpha Beta, the financial manager at the mini picnic restaurant, is checking to see if there is any relationship between Instagram advertising and the sales revenue at the restaurant. She obtains the following data for the past 10 months. So here is the advertising cost and the revenue. And she estimates the following regression equation as stated here. Okay, so for the first one, we're gonna plot the relationship between advertising cost and the revenue, and also to draw the regression line and evaluate it using three criteria. First thing first, we're gonna identify which one is the dependable variable and which one is the cost driver. So here is the cost driver, which is the advertising cost that influence other variable, or here is the revenue. To plot the data, we're gonna block all the data and insert the chart using the scatter one. Here, as you can see, is for example in point 1 is the data from June, which is the advertising cost 500 and the revenue is 56,000. Next, we're gonna give the regression line here. We're gonna choose the trend line using the linear one. Then we're gonna continue to the evaluation. Okay, for the first criteria, which is the economic plausibility, the advertising cost appears to be plausible, which is it is the cost driver of the revenue, where the higher advertising cost, the higher revenue that mini picnic will get. The second criteria, we're gonna see the difference, the vertical difference between the point to the regression line. So here the vertical difference is quite small, so it indicates that the advertising costs are related to the restaurant revenue. And for the third criteria, which is the slope of regression line, we're gonna see from the slope of the regression line here, which is relatively sloping, so the change in the advertising cost doesn't significantly affect the revenue. So that's three evaluation that we can give using three criteria here. Moving on to the second one is use the high-low method to compute the function relating advertising cost and the revenue. Here we all have the data for the February to November. So we're gonna identify which one is the highest cost driver and the lowest cost driver. For the highest cost driver, it is 4,500 advertising cost in September. So this is the highest. And for the lowest is $500 advertising cost in June. Next, we're gonna find the difference between the highest and the lowest. So for the highest advertising cost is 4,500 with the revenue of 83,000, and the lowest advertising cost is 500 with the revenue of 56,000. After we get the difference, we can find the coefficient b from the basic function we have here, which is the y equals a plus bx. For b, we're gonna divide the difference of dependable variable, which is the revenue, divided by the difference of the cost driver. Here we get the b for 6.75. We're gonna moving on to find the a. So a is equal the revenue minus the b times the advertising cost. So you can use either the highest or the lowest data. Here I will use the highest one. So revenue of 83,000 minus B times the advertising cost, which is 4,500. So the A is 52,625. After we get the A and B, we will put it in the revenue function. So the revenue is 52,625 plus B, which is 6.75, times the cost driver, which is the advertising cost. Next to the third one is using the regression equation and halo equation. What is the increase in revenue for each $1,000 spent on advertising within the relevant range? And which method should beta use to predict the effect of advertising costs on revenue? So here is the regression equation that we get from the problem here, and the halo equation from that we have counted before. Then we're gonna put the $1,000 here in the advertising cost, and by using the regression equation we will get the revenue of $53,027, while when we use the halo equation we will get the revenue for $59,375. So which method should be used to predict the effect is to use the regression equation. Why? Because it uses all the information from the data from February to November, while the halo method is only using two data, which is the highest and the lowest. So it doesn't really represent all the data. And that's for problem number 1. Next, we're gonna continue to problem number 2, which is the halo method. So here is Aqua Manufacturing Company produce inventory in a highly automated assembly plant in Karawang. The automated system is in its first year of operation, and the management is still unsure for the best way to estimate the overhead cost of the operation for budgetary purposes. So here are the data for the first 6 months. It has the machine hour, kilowatt hours, and the total overhead cost. First, we are required to use the halo method to determine the estimating cost function with machine hour as the cost driver. So we're gonna identify the highest and the lowest cost driver first. Here is in June as the highest, with the total overhead cost of $139 and $200. Next, for the lowest is in September, and we're gonna input the total overhead cost too. After that, after we get the difference of the highest and the lowest, we will find the B, which is 19,200 divided by 800. So the B will be $24. Then we will find the A, which is total cost. I'm gonna use the lowest, which is 120,000 minus B, 24 times 3,100. So we get the A and B here, and we're gonna put it in the cost function. So the total cost is 45,600 plus 24 times the cost driver, which is the machine hour. Next, for the number 2, use the high-low method to determine the estimating cost function with kilowatt hour as the cost driver. So we're changing the cost driver. Before we use the machine hour, now we're gonna use the kilowatt hour. Here, for the highest one, is in April. We're gonna put it in the total overhead cost. And the lowest one is in September. Then we're gonna subtract it and get the difference of the highest and the lowest. Next, we will find the B. So the difference of dependable variable divided by the difference of cost driver. Then we will find the A. I'm gonna use the highest now. So it is the total overhead cost minus B times the highest of the cost driver, which will result in minus 55 and 400. Okay. So we will get the cost function here as the total cost equal minus 65,400 plus 0.0445 times the cost driver, which is the kilowatt hour. Okay, we already get the cost function with the 2 cost driver. And in the third one, for October, the company ran the machine for 3,000 hours and used 4 million kilowatt hours of power. And the overhead cost total $114,000. So which cost driver was the best predictor for October? Here is the equation for the machine hour as the cost driver and the kilowatt hours for the cost driver. For the machine hour, we're gonna use 3,000 as the machine hour that is used in October, and will result in the total cost of $117,600. While when we use the kilowatt hour as our cost driver, we will get $114,600. So when the best estimator for October was the kilowatt hour, because the result in here is the difference is relatively small between the overhead cost and the estimated cost using the cost driver, the kilowatt hour as the cost driver. Yeah, I think that's all for today's session and the exercises. Thank you and see you soon.